All right, so today we got to remember factoring, and some of you aren't going to like that already. But one thing I know is when I'm taking care of fractions, they are in their simplest form. So rational expressions, which are fractions, okay, are in simplest form when its numerator, if you don't remember what that is, the top, and denominator, and again, if you don't remember what that is, that's the bottom, are polynomials that have no common factors slash divisors, stuff we can take out, okay? So what I would want you to do is use your graphing calculator to sketch this out. And what you need to do is this really is just y equals, and you're going to plug all of this in parentheses and then divide it by all of this in parentheses. So take a second, check it out on your graph, what it looks like. What's going to happen is you're going to see something that kind of goes like that, and this line doesn't actually exist on the calculator, okay? If we were to factor this out, that's what I kind of like to do first here is, well, just kidding. Let's just keep going here. What stands out as we view the graph? It looks like there's kind of a break at -4. Like it kind of goes down and then it looks like there's this big line at -4, okay? That is called an asymptote. We've talked a little bit about that with our horizontal asymptotes when we're dealing with chapter 8 with exponential functions that just went up like this and never below that x-axis, okay? What you don't see is the whole at x equals -5. Now I would show you this on decimals in class. You could graph this in decimals on class and then go to the table button and press, there's like a gearbox looking button, and you press on that and then you press table and it'll come up in a table, and at -5 it'll say undefined. Okay, it'll actually say that at 4 as well, at -4. Okay? Because, well, actually that's kind of what we notice from the table, is that it's undefined at x equals -4 and x equals -5. Okay? So there is no value at x equals -4 or -5. Okay? Why does that happen? Well, first of all, let's go sketch this graph. At -4, we've already said that is an asymptote. That is a point that does not exist. So we're going to draw kind of a vertical line there, and we can't go past it. Now I'm going to also tell you, you'll notice it kind of goes up here and then it kind of starts like this. There's actually something called the horizontal asymptote right here. We always get those. I'm not going to ask you to graph these this chapter. I do that with my honors class. I don't do that with my regular class. But what happens here is a horizontal asymptote is found by just dividing the leading coefficients. So 1 divided by 1 will give me 1, and y equals 1 is my horizontal asymptote if the exponent is the same. There's rules with that. Don't worry about that now. What I want you to get at is from the table, we see that there's a point on this thing, like for instance, -1, 2, 3, 4, 5. Well, that doesn't exist. We already said that, right? So I'm going to look at -6. -6 is right about there. I don't remember what it was, like a half or something. And so that means that this thing hugs the asymptotes. But at this point, it does not. It looks like it crosses through the 0, but that's a hole that does not exist. I'm going to explain why in a little bit. And on the other side, if I just plot like -3 or -2, well, -3 is +2, so it hugs the axis that way. Why do we have undefined values? Well, that's because restrictions occur. And this is a word that you need to get used to. Restrictions happen when denominator cannot equal 0. We're going to talk about that, okay? You cannot divide by 0. Try it in your calculator. 7 divided by 0. It doesn't work. So you need to state the restrictions. So there's really two parts of this problem. And this is good review, really, of things that we've already done. It's factoring and it's finding zeros, okay? As part of your solution, and the reason that I want you to do this is because points are undefined at these, x values. So, does not exist. DNE does not exist. Okay. I'm going to do the first 7. I'm going to ask you to pause it and do the next 7 because they look just like it, and then you can come back and check your answers. So, for the first 7 there, these two problems are GCF type problems. What goes into 24 and 56? And some of you might say 2, and that's not wrong, it's just going to take longer. If you can find the greatest factor that goes into them, like 8 goes into there 3 times, and 8 goes into there 7 times, then we don't have to keep reducing. For the x's, I can take 3 x's out of here, I can take 3 x's out of here, and I'd be left with 2, and there it is, my answer all by itself. Just reducing the fraction. Okay. For the next problem, if I can't, I could take a 4 out of all of these terms. Okay. I could take a 4 out of here, I'm left with x. I could take a 4 out of here, I'm left with 5. I could take a 4 out of here, I'm left with 3. And so my simplified answer is that. Now, what I didn't do is state the restrictions. To state the restrictions, we literally just set what the denominator equals to 0. How do I solve this? Divide by 7 and square root, so x cannot equal 0. And that's what I'm trying to get at, is our restrictions are x, what x cannot equal. When there's no x in the denominator, which is not going to happen very often, then there are no restrictions. Okay. So, for the next problem, I can't take something out of all of those terms. So I need to start thinking GCF of just the top and GCS of just the bottom. What goes into both of these terms? X, when I pull an x out, which means really I'm dividing an x out of both of those terms. It still goes on the outside. If I take an x out of here, I'm left with an x. If I take an x out of here, I'm left with a 4, and I have that on top. On bottom, I can only take a 3 out. If I take a 3 out of here, I'm left with x. If I take a 3 out of here, I'm left with 4. Now, you know that 3 divided by 3 is 1. You know probably even that 3x divided by 3x is 1. Do you know that x plus 4 over x plus 4 is 1? Plug in any number you want into that. 5, then I'd have 9 over 9. 10, then I'd have 14 over 14, etc. Even negative 4. Well, that's the one that it can't be, but we'll get to that. These cancel, and my answer is x over 3. Now, to find my restrictions, which is the second part of these problems, I set the denominators equal to 0. If I set 3 equal to 0, there's nothing I can do there. If I set x plus 4 equal to 0, I would minus 4 to both sides, and I get x cannot equal what my restriction is, which is negative 4. So really, there's 2 parts to every answer. The solution simplified and the restrictions. Okay? Let's go on to number 4. In this problem, I'm going to have to do one of these kind of things, product of binomials. 2x is a prime number, so I can go 2x and x. On bottom, hopefully you recognize this as difference of squares. This is x plus 3, x minus 3. I'm going to tell you, I'm likely going to give you problems that cancel out. So either x plus 3 or x minus 3 is probably going to go right there. So the factors of 9 are 1 and 9, 3 and 3. Because of what I just said, I'm going to put a 3 and 3 there and try and figure it out. This would give me 6x. This would give me 3x. To get a positive, that has to be positive and that negative. So positive here, negative here to give me the negative 3x, right? Now I can see this and this cancel. So I've got my answer, 2x minus 3 over x minus 3. And then what x cannot equal is setting my denominators equal to 0. Again, I'm just going to put it here. Equals 0, I do the opposite, get negative 3. Equals 0, I do the opposite, get positive 3. And there's my answer. If you wrote that as plus or minus 3, it's the same thing. Okay? Number 5, the next problem. Again, factor the top, x and x. Factor the bottom, x and x. The factors of 25, 1 and 25, 5 and 5. Well, that's what's going to give me 10 if they're both plus. Factors here, 2 and 10, 4 and 5, 1 and 20. I'm probably looking for a 5 somewhere. So let me go 4 and 5, and sure enough, it's plus plus. These cancel. I could have canceled this one and that one, but I can't cancel this with both of those. And I get x plus 5 over x plus 4, and my restrictions are, again, setting this equal to 0 to get negative 4, setting this equal to 0, do the opposite to get negative 5. And there's my answer. Okay? You can see I'm just factoring over and over and over again. This one here, same thing. I'm going to factor the top, 2x and x, and factor the bottom to get x and x. The factors are 2 and 3 and 6 and 1. If I use 6 and 1, 6 minus 1 will give me, or negative 6 plus 1 will give me negative 5, but a negative times a positive will give me a negative here, not a positive. So this is minus 2 minus 3. Negative 2 and negative 3 give me the negative 5, and negative times a negative will give me a positive here. Likely that's going to show up in one of these, so I've got the factors of this are just 2 and 1, so I bet it's there. And if I multiply the outside, I get 4x, the inside, I get 1x, negative 4x, positive, and that probably should happen because I'm going to give you something that cancels. So my answer here is 2x plus 1 over x minus 3. X cannot equal the opposite of that, which is 2, the opposite of that, which is 3. Same thing over and over and over again. Even on the next one, although it is substantially harder than all the rest of these, because I wonder if you even see on the bottom that this is difference of squares. It's a minus sign, there's two terms, I can't GCF it, the square root of that and the square root of that give me the numbers I need, okay? Just like here, square root of that and square root of that. On top, well, there's something I gotta do here. I'm gonna write it up above because I don't have a whole lot of room here, okay? I've got 4 minus 3x. If I pull a negative out of both of those terms, so I'm gonna pull a negative 1 out of this, which means, again, I'm dividing a negative 1, I'm dividing a negative 1. Okay, and then if I rewrite this as negative 1 times, switch them around, positive 3x minus 4. Well, then I can rewrite that here, okay, and then I can cancel those out. I can't cancel 4 minus 3x with 3x minus 4. I need them to be the same, and I just pull out a negative to do that. Well, look, there's my answer. And my restrictions are, set this equal to 0, what would you do? You'd minus 4 and divide by 3. Set this equal to 0, you would add 4 and divide by 3. There's my restrictions, there's my answer. There's two parts, okay? Press pause, try the next 7. They are just like the previous 7 I just got done with. Come back and check your answers. I'm going to quickly go through them as I'm doing it. Anytime x is by itself, there's no like 2 terms, 2 terms, 3 terms, 3 terms. You're always going to get 0, by the way. Okay, you can see I'm kind of flying through this. 2 goes into both of those. I set that equal to 0 to get my negative 3. The biggest thing that students want to do here is they want to try and cancel out these x squareds right away. That's not how any of this works unless it's a monomial. That's the only time you can do that, okay? Like in this one and like in this one, okay? All the rest of these, you need to factor these out. This next one is kind of a bugger to factor, not necessarily the bottom, but the top, because I know I gotta have 3x and x, and I know I gotta have either 1 and 2 or 2 and 1 to give me a negative there, or a positive there and a negative there. It's really a minus minus. So if I put 2 here, I get 6 and 1 to give me 7. I need to put 1 here, or excuse me, 2 here, and 1 here to give me negative 2x and negative 3x to get that negative there. Negative times negative gives me positive. Up at the top, the factors of 6, the factors of 6. But again, if I do the bottom, I know I'm going to have a 3 and a 2 to be able to cancel, or a 6 and a 1 to cancel. So that doesn't even help. It's really a guess and check. I'm going to just write the right answer in here. It's 3x and 2x. So I've got to get 5 in the middle. So if I go 2 and 3 again, I'd get 3 here to give me 9 and 2 here to give me 4. 4 and 9 will give me, as long as that's positive and that's negative, which again, once I see that, these are going to probably match up, so I get something to cancel. You get, well, 2x plus 3 over x minus 1 and x cannot equal, set this equal to 0, I'd add 2 and divide by 3. Set this equal to 0, I'd add 1. And I get both of these two as my answers here. The bottom you can see here is x and x, 5 and 2, plus 5 minus 2. Brain fart there for a second. On top again, I could factor out a 2 out of this, or a 3 out of both of these and get 2 minus x. But again, 2 minus x and x minus 2 do not cancel each other out. I got to pull out a negative 1. If I pull out a negative 1 out of both of these, I get negative 2 plus x, which is negative times 3 is negative 3 times x minus 2. Now these cancel. Okay. And x cannot equal negative 5 and positive 2. Okay. So as you've noticed, there are some stuff that cancels. We still need to rate our restrictions for those as well as the ones that don't cancel. Okay. This is it. It's really, again, it's a bunch of just remembering how to factor and remembering that factors cancel and remembering how to find zeros. It's putting kind of a bunch of things together that we've done this year. Your homework, I don't know why this is stapled. The next page is exactly the same as the first page for some reason. So you can cross that. That's just notes again. It's the same exact thing. Your homework is this practice 9-4A, and I want you to do 1 through 20. You should get some time in class to work on this today. So I would start with the stuff that maybe you're struggling the most with, like for instance number 20, number 19, maybe even 15, and 1 through 4. 1 through 4 seems to get some people. So any questions, let me know.